Hi guys and welcome back. So today we would like to work on macros, specifically procedural macros. So in Rust, there are basically two kinds of macros. They could be declarative and they could be procedural. So if you've ever had to use something like, let's say maybe I start a new project, because if you look over here, I just created an empty folder. So maybe I start a new project so we can always write some things down. So I can say cargo init, and I'm just going to use my current space. So if I come in here into the main file and I have this macro over here called print line. So this is a declarative macro, which you probably have had to use sometime in the past. But again, like I said, our focus for today would be procedural macros. So procedural macros themselves, if you've ever had to, let's say, I can come up here and define a struct and give it a name, student. So if for this struct, I have the option of actually coming up here and say derive. Now I have to, of course, do it like this. And now I say derive, and maybe I add debug, for example. So adding this derive up here, this is what is referred to as a procedural macro. So these are really a powerful meta-programming feature in Rust, and that allows you to extend the language syntax and generate code at compile time. So meta-programming simply means writing code that writes code. That's really the point. So they provide a way to abstract away repetitive code patterns and enforce coding conventions. So creating like domain-specific languages, popularly known as DSLs. Yeah, so but working with procedural macros can quite be challenging. I also know because it was for me. That's also what I would like us to simplify basically in this tutorial. So if you find the need to incorporate or write your own macros that does specific tasks for you, that would be the idea of this tutorial, to help you do that more efficiently. So imagine, for example, a scenario whereby you would define a struct. For example, here we have student, and then we want to implement a lot of functionalities on this student. And that also means maybe we might decide to implement a couple of threads and then have implement those threads for this student struct. So this list could grow. Of course, over time, this could really grow. And what this might mean, that we would end up having to make a lot of manual implementations, like having to manually implement all these threads for all our structs, or whichever structs we might have that needs to have those threads implemented. And of course, this can be really repetitive and redundant, and that's really where macros shines. I'm not going to say specifically procedural macros, because of course that's also the same for declarative macros. That's also the case. So if you, maybe I can also show you a quite simple example of how declarative macros work. Is also quite pretty straightforward. So you declare them basically with or another declarative macro that's already pre-written for you, called, like, it's called macro rules. So you can simply say macro rules, and you can see here, this also basically shows you what this structure could look like. So here I could create a simple one called add, nothing so fancy, and it's going to take two arguments, and I'm going to represent those as, of course, this would be expressions. So I can pass those in here. I'll probably call them A and B. So this is going to be expressions, and then the second one would also, like I said, we'll call it B, so expression. And what do we want to do with this? Is pretty straightforward. So in here, I'm going to define, of course, the body of the struct, and it's pretty straightforward. Here I just want to do A plus B. That's it. That's really all we want to do for this example, and really our macro is done. Down here I cannot just print this, and I can say the result of 3 plus 5 is this, and then I can just inject that into this print statement. So simply here I can call our add, and then I provide 3 and 5, as simple as this. So now when we run this, of course, we should be able to get our result. As you can see down here, 3 plus 5 is 8, as simple as this. So this would be, of course, declarative macros. It of course gets more complex than this, but again, that would not be the sole design for this tutorial. Here we would like to focus more on our procedural macros, which in my opinion are much more tricky to handle or work with. So let's really jump right in and see what we can achieve today. So to proceed, what I would like to do basically is I'm just going to come down here and create a new folder. I'm going to call this crates in the root. And now what I would like to do is simply create, because when we are working with procedural macros, we will not be able to test it within the same project where we write it basically. So that's why I would like to create it separately as a library package, and then of course use this in our main project. So what I can now do is cargo new, and I can show you an example. I can call this maybe lib1, and this is going to be as a library, and I also like to put this in here. So I say creates /lib1. Oh, my bad. And what would happen, of course, would be we'll see in here we would have this new project created for us. Of course, it's also, as you can see, within the source file, we have this librs. And what we can simply, of course, do to um, maybe what I can also do is just go ahead and add everything I need. So I'm just gonna now call this. I can call this custom macros. So that's also going to be, if I expand this crate, we'll see that's in here as well. So now with this created, what I can simply do is come into cargo mode. This would be our root. And then I can come in here and create a new section. This would be for workspaces. So under workspaces, I can now add the members. So members from me would be creates / lib1. So this would of course give us that first package, and the second one of course will be at create / custom macros. So this would also give us the second one. And now what I can actually do is I can come under dependencies and of course inject this into our main package. So I'm just going to call this one lib1, and for this I simply would provide a path. So the path would again be simple. So it's going to be at create / lib1. Okay, and then we also do the same for the second one. I call this custom macros. I provide a path. Path again is going to be at create. I hope I'm writing that out as I should. Custom macros. So let me see. So that's currently written. Creates that's also currently written. And so that's really all I need to do to, of course, add those libraries, of course, into our main one. And then I can simply come inside our main file, of course, within the root, and add those packages so that I'll be able to use them. And now what I can simply do is up here, I can say extern, I add the crates, extern crates. Now I'm just going to add lib1. And now, of course, I can also add the second one. Of course, there is no need to. So custom macros, and now we have those within our main project. So now I can go in here, for example, and so in here we have a function called add. And I think we should also have something similar in here. So now what we can simply do is I can try to import those. I can say use lib1, and I now have access to add from lib1, and I can also do same from our custom macros. So what was it? Yes, add as well. And what is, yes, of course, we have a conflict in the names. So what I can also do now is maybe call this as other, something like this, so it doesn't conflict with the one we have up here. And now down here, I can simply, of course, call these functions. The results common from lib1, and here I simply call this guy add, And again, I say 3 and 5 or whatever. And I simply also do the same for the other one. So I'm just going to copy this again, come down here, dump it, and now call this guy other. I'm also going to change that here. And now this would be custom macros, something like this. So now when we run this, let's see, we have some error. Let me see. Of course, here I'm using the wrong command, so I'm just going to clean all of this. Now say cargo run, and we should be able to run our code. And now you can see. So now we have more or less confirmed that we are able to invoke the crates, the one we have within our crates folder. So currently we have lib1 and custom macros. So now we would really jump right in. We'll go into custom macros and of course that's making our implementations. But we still have a few things we would need to, of course, do to get to properly set up this crate over here and then to be able to actually go further and work with it. So what I can now do is go inside of our custom macros, go to our cargo terminal, and I'm going to make a few changes so we'll be able to, of course, work with this. So I'm going to add a leave session. And within this session, the most important thing I need to add here would be proc macro. If we do not do this, we would not be able to work with proc macro within this package. Like we cannot create procedural macros in this crate if we do not meet, or if we should we skip this step. So I would like to add a few features here, a few attributes. So I'm going to give it a name. Again, I'm going to stay consistent. So the name is going to still be custom macros, and the path, of course, it's going to be at source librs, and that should be fine. So let me see. Yes, of course, we can no longer have something like this because within this package, we cannot export functions as this. So, but that's totally fine. And so within here, of course, within our dependency section, we've added, now I need to come back in here. I need to add a few packages that we'll be using to, of course, to create our procedural macros. So one of them would be scene. So I'm going to be a little bit specific here. So I provide the version. Version is going to be version 2.0, and features, I'm just going to make it full. So the next crate, of course, would be quotes. I'm just going to go for 1.0, and the last but not the least for now would be proc macro 2. So it's going to be, the version is going to be of type 1.0 as well. And that's basically all we need to get started. So let me come in here. Now what I can actually do is to remove all of this. But what I would, of course, we would now have this error because we don't have this function anyway, but that's totally fine. So I'm going to come in here, I will collapse all of this and create, like you normally do, a readme. Just to give you a quick rundown of what I would like us to, of course, cover in this tutorial. So I will really cover a lot of examples in here just to make sure that we really drive home the points and that you also see different angles as regards creating macros for your own use case. And because of that, I've prepared like 4 interesting points that I think we should consider, more or less 4 macros we would have in the end afterwards. And so I'm going to come here and say, I don't know, content. So the first thing I would like us to do is to create a macro. I'm just going to call this query builder. So what this is going to do for us basically would be, so imagine that we have a struct that like we do over here called student, and the student has, say, it has first name, which happens to be a string. It has last name, which happens to also be a string, and maybe also has an ID, which happens to be, let's say, I64, for example. So imagine this represents a student, and this student, of course, we can map this to our database table. So what I would like us to do with this query builder macro would be that I should be able, for example, come in here and say let student equal to so of course I say student no student, and I should be able to come in here and provide some attributes of this struct. So in that case, I'm going to mark all of this as optional. So this will be string. So in this case again, this would be option, and of course maybe ID would not be option. So what I would like to do is that I should be able to come in here, for example, and say ID is equal to, I don't know, 23, and I can say first name would be, I don't know, none. Come on. And I can also say last name would be none. I would like to be able to do something like this to represent a student's table on a database. And then what this should do for me would be to generate a query for me. And that query would be based off of the attributes of these structs that are not none. So in this case, I would expect the macro to be able to return something like this. So the query would, I want this to give me back would be something like this. Say maybe select all from maybe students where ID is equal to some ID, in this case 23. So this is what I want to do. I want to create a structure like this so that in this case, if I should come in here and provide a first name, let's see, something like string dot from, and I say Tony, for example. Now I want this query to become something like this, and first name equal to Tony, something like this basically. So that's what I would like this first struct to do for us here basically. Pretty straightforward, I guess. The next one I would like to do would be I'll call this getter and setter. So what this should do for us, it should be able to, when we of course apply this to a struct, it should be able to implement getters and setters for us for that struct automatically. So what it means is in this case, now that I have instantiated an instance of students, it means I should be able to come down here and now say student.get ID, something like this, and it should give me the ID. That's really what I want this to do for us, the second one. Okay, so the third one would be more or less in the direction of design patterns, as it pertains to like writing like more readable, more professional code, more or less. So I would like us to implement two macros that would in turn of course implement or generate for us the source code for implementing two um, software design patterns. One of them would be, of course, the builder pattern. We've already talked about this on this channel. If not, I will leave a link so you can, of course, go back and take a look at it. And the last but not the least would be we would also implement a macro that's going to in turn implement a factory pattern for our structs. So these are the four kind of macros that I would like us to cover in this series, so that in the end you should be able to implement any other kind of macro you would want to for your own specific use case. So based on what we just described, I would like us to, of course, start with the query builder. So I can maybe specifically say SQL query builder. So again, this is just for simplicity, and this is really going to focus on um, select statements for now. So no complex, crazy SQL, whatever. And we're just gonna keep it as simple as possible. Anyways, I'm just gonna come in here into our custom macros, and now I would like to define, of course, a function. So I can call this or maybe I call this query builder. Say maybe query builder, or let me be specific and say SQL query builder, something like this. This is going to be, of course, the function name, and it's going to take a token. So this is going to be of type token stream, and it should be able again to return token stream. And of course, I would like to annotate this function. So here I need to add proc macro derive, this one. And then in here, I would like to now give the name of the traits that I would like us to derive. So I'll call it SQL query derive, something like this. And of course, we're getting this error now because we are really not returning anything, but more or less this is how the implementation for us will look like. And what it means now is that inside our main file in here, of course, we don't have something like this anymore. And what I can also do is now I can say use custom creates, and now I have my SQL derive, for example. And now what I can simply do is to copy this beside debug. I can just dump this in here. And now our query, of course, would have been implemented. So, but again, we have not implemented this. So that's also why we get the error that we get right now, because basically nothing is being returned. So again, when our language server tries to let this unfold into the actual code, it basically gets nothing. So that's also why we get this error over here. So failed to build proc macro. So, but anyways, now I would like us, of course, focus in here in the implementation detail, and then I can show you basically how this works. So how I would like us to use this macro would be, I want to be able to come in here, and when I've applied this macro, I also want to be able to come here and again add an attribute macro. And what I'll be expecting here would be something called table name. So this would be how I receive the name of the table. And in this case, it might be something like student, for example. Or maybe even make it in plurals as students. So now I can come back in here and actually start making the implementation. I would implement this in steps so that I don't just dump the code on you, but also that you understand what is really going on. So the first thing I would like to do would, of course, be to pass the input. And again, I just forgot. So now, because I added a new attribute here, again, this would be an attribute macro. So maybe I also add a comment here. This would be an attribute macro, just for your information, basically. So I'm just going to copy the name, come back in here where we are implementing our macro. And then I would need to add additional information to our proc macro. So in here, I can, of course, now add this here as attributes. So this should be attributes in plural. And then within these attributes, I can now provide the additional attributes I expect to also parse. So after this, the first thing now, again, like I was saying, would be to parse the inputs that I'm getting. So I can say let input would now be there is a handy function called parse macro input, and in here I provide the inputs, and I would like to, of course, type this. So I say inputs would be as derive input, like this. And again, I can also double click for this to give me what I want. So now after passing the sorry, this should be my bad token. That was what I called it. So yep. So after passing the input, the next thing I would like to do at this point would be to get the struct name. So I can call this let's name. I can give it, just call it name. So name would be input dot ident, and I can also double click this to give us that's actually. And the next thing I would like to do would be to maybe extract the default values for our table. And also, of course, we don't have to worry about the extra derives because in this case, I'm also using like the version 2 of the same package. So we should be totally fine. So what the next thing I would like to do would be, I'm just going to call this maybe default values. And then in here, I would like to extract things like the table name. So I have to create a table, an argument, sorry, called table name. And for now, I'm just going to make it an empty string. So I say to string. So this will be the table name. And again, I need some params. This of course would be what would have to pass in the end, but I would like to create a default value for this as well. So I can come on and say params. Is going to be just a vector.new, and in here I would make this, I would expect this of course to be a vector of strings. And now what I would like to do would be to pass the attributes that we get from this input arguments. That's basically passing the token tree that we get for this um, macro. So what I would like to do would be to loop through all the attributes that we received from our derived input and then handle them accordingly. So it should be pretty straightforward from here on. Or maybe to keep it simple, I'm just gonna forget about this for now. I'm just gonna for now focus on the table name, and then we can really proceed from there. So I will loop through all the attributes that we received, because the first thing I would like to do would be to, of course, manage this table name. So if it is provided, if it is not provided, of course, I would not like to move further. So I should be able to give the basically terminates the should not be possible to move further, as simple as that. So I'm going to loop through all the attributes that we get from the input stream. So I can loop through, of course, maybe I pass this as reference. I say input dot attributes. So I would like to loop through all this and then again handle the table name attributes, the one here. So what I would do here is, of course, to see if we are able to, if it is even possible to get these attributes. If attributes were even provided in the first place, then we would decide how we want to process this. So I can say let sum, and in here I'm just gonna maybe call this attributes method name. And this name, of course, is going to come from attributes.path. And then I call get ident. So if this is the case, if we have this, now I need to check through the attribute method name. So, but before I proceed, of course, I'd like to explain to you what this path here actually means. So if I come over to the main file, for example, here where we have this derive keyword here, and within brackets, we have a bunch of other traits in this case. So if we wanted to pass this of course would be passed as a list. There is, so in here, I should have this meta, this one. So within meta, I have the option, of course, I can show you. So here I have the option, of course, handling a list, a named value, and a path. So that's, I'm trying to explain, of course, to you why we had to go for the path here. So again, if I come back in here, this would be in a list. Something like this is also can be considered. This would be like a path variable. We can, of course, extract. That's also why we're extracting this as a path variable. We can also add something like this. I don't know. I can give it a name, maybe give any name that I want. Again, this will also be an attribute macro, and this could be something like some, I don't know, some attribute. In this case, we can also access this as path, of course, just like we would for the table name, because also in here we can actually even add expressions and make it as maybe as complex or whatever we want to be. But the interesting thing, of course, is that the arguments we pass right here when we are creating a macro, depending on how we've defined them, we could access them as either a meta list, like what we see here, or we can access it, of course, as a path, or we can also access it. The last one will be as a named value. That's really the interesting thing I just wanted to show you here. So just keep these three things in mind. So this will, of course, help you to know how to extract the value added anyways. So let's come back in here. So we have, do we have any errors? Yeah, it's fine. So in here, what I will now do, of course, is I now have the attribute name, and now I now need to check, of course, if it is table name. So I can simply say if this attribute meta name is equal to table name, like we said here. So if this value here is equal to table name, for example, now what I need to do is just to evaluate the expression within the table name to now extract the actual table name. Again, remember here is not just table name, we are passing this an expression. So within this table name, we are passing a string called, in this case, students. So once we have this extracted, now I would like to parse the content of table name. So in here, I can simply say, let expression, and expression is going to be of type attributes. And in this is attributes, I would like to pass the args, to pass the arguments passed to this attribute. So I'll probably put this in 2 lines. And then down here, what I would like to do, of course, is to handle the error. So I can say map error like this, and I'm probably not going to pass anything in between. So, but I would have to handle my error in such a way that it is reasonable for the user, that we use our macro to understand what kind of error they are running into. Okay, so in here I can say saying error, and I would like to, of course, create a new error. And so for span, I'm just going to say attributes.span, and so for message, it's going to be pretty straightforward. I'm just going to use a format macro. So within the format macro, I'm just going to add a string. So that's not what I wanted to do. So I can say formats, this guy, and I can do it like this because I would like to, of course, make this a string. So I can do something like this. And of course, I close it up. And then in here, I would like to say a few things, for example, so I can say something like maybe add it like this, the table name attributes, for example, I say expects a string literal, something like this. I think this should be enough. And then down here, I can maybe do something like, I say something like help, and I can say use. And then this here would be something like, I can now show the user more or less an example how they can use this. So I can say table name and give it a name users, for example. And then I close this all up. What is this? And then I close this all up. Now this should, of course, be able, the user should now be able to use this. And now down here, what I can now simply do is I can call unwrap. So let's see. Yes, I think this should be fine. And now the next thing, I think this should be okay for now. So at this point, we should be able to have our table name. So, but I would like to fix this error. It seems I have some annoying error here. Okay, this still has to do with my return statement. I can't really do much about it for now, but let's proceed. So once I have the table name, what I would really like to do maybe down here would be to assign it, of course. So here I can say table name would now be if equal to, so I can say expression into token stream. Of course, we have our expression over here. What is the error? So I can go back. So into token stream, and of course I will then convert it to string like this. And this, well, let me see, for loops, of course, yeah. So anyways, let's proceed. This would go away in a minute. So the next thing I would like to do is to check if the struct has named fields. So I can say let fields. This would be, I would like to match the data. So I say input the data. And what I would like to do here, of course, is to, again, maybe check if this provided struct has. So if you provide like an empty struct, we should have some problem. Basically, that's what I'm trying to do. So the data, of course, the data should come from, I should be able to say sin data, and then of course in this case is a struct. And so in here, of course, I need to pass a reference. I can call this data struct. This would of course be the content of my struct. And now I can add another match here. I can match the data structs. Come on, data struct fields. I'll match the fields of the struct. So again, if here I need to, I can simply do the same. So I can say saying fields, and I can call named. So if we have this again, I reference of course the field name. So I can call this again fields. I can say something like named to show me this is also what I would like to do. So the name is actually the field struct field is actually named. So here I can say fields named dots named to of course have access to this. And of course, that's the only thing I'm interested. Every other thing, if this is not provided, I would like to basically panic. So here I can say something like, what is the name of our, let's copy the name, come down here. So I can say something like this. This can only be derived for structs with named fields. So that would be what I would like to do here. And of course, if this is not even the case, so again, we only care about structs. So if that's the case here, it means this is not even a struct. So what we can actually say is this can on, only be derived for structs, something like this. Okay, and now we have our fields go away. So I can come down here and of course now do the interesting work, which is to generate the SQL, as I say, SQL query, something like this. And now this will be the interesting part. I'm just going to call this expanded. So this is going to be our token stream that will return to the user in the end. So I would now use the quotes macro to, of course, add the implementation of this. And maybe in here, I can already take this out like this, and now I can say token stream, and I say from, and I add expanded like this. And of course, now our function or our macro more or less should satisfy the return type here. But we seem to have some error here. So our meta, we have an error. Of course, this is not annotated. That's also not a problem. So I already know the type is going to be of type expression, like this. So now what is the error? So expression into token stream. Let me see. So we seem to, of course, not added a dependent trait. So it's also what's I'm getting here. So again, interestingly, I can come up here and paste this, and of course, this should be fine. So, but the interesting thing now is this is returning a token stream, of course, as what we expect it to return in the end. So now let's do the interesting part inside here, inside quotes. So basically, as you can already have imagined, quotes macro would help us return the token stream in the end. That's also what you see over here. Okay, so now here what we would like to do is to implement some methods on our struct, and that was also why we got the name of this struct up here. So in here I can reference that in here by saying import, because again I like to implement some fields or some functions more or less on this, but I cannot reference this like this, because this would not work. So I have to, of course, reference this using this pound sign. So I can say input name. So in this case, name would of course be the name of the structure, like we said in the beginning. And in here, I would like to implement a method called build query. So it's going to take a reference to self, and in the end, it's going to return a string, which is also exactly like what I showed you here, something like this. So let's continue. So in here, let's of course provide the implementation. So now I would like to get to the query part. So I create a vector called query parts. This is going to be of, I'm going to say vec.new, and now I have my query parts. Now the next thing, of course, I would like to do would be to iterate over my query fields. And so instead of using a for loop to loop through all my parts, there is a handy way of doing this. So I can actually use this syntax. So in here again, I reference that part called query fields. Where is it? Um, I think I called it just fields. Again, maybe to make it consistent, I'm gonna call it query fields. So I'm just gonna copy this, put that in here. Come on, copy, paste. And now, of course, I'm considering this guy, and then of course I add my this to close this off. So this, of course, is going to help me instead of writing some fancy for loop to loop through these fields. I can just expand this just by using this shorthand syntax. Okay, so now what I can actually do is to check if my parts are empty. So again, this is one way, of course, for us to decide what kind of query we return to the user in the end. No, I think I made a mistake. So this is fine. I'm just going to call this parts fields. And of course, what I need to do would be to generate the query parts again from these fields, because if you remember, what we have until this point are just the fields and the field names of our struct. So what I can do is to come here and add a new step, and I can now say something like generate SQL field checks. I say for each of the fields of the struct, something like this. And now I can now define my query fields. And again, it's going to be pretty straightforward. So I'm going to loop through my fields. So I can say field.iter to iterate over my fields. So I put this in a new line. And then, of course, once I have this as an iterator, I can add a map. So this map, again, is just going to take a field. Again, in this case, looping through the fields that we already extracted. And then what I would like to do, of course, is to get the name. So I can say field name would, of course, be something like, as pass this by reference. I can say field.ident. And I also get the field name string. So I can say field name str. And this is going to be from field name, and I take this as ref, so as ref, and I can now unwrap and then to string. So maybe I put all of this in new lines. So or I can also leave it, it's fine. So with this field name, what I would like to do, of course, is now to check if any of these fields is sum, and then we include this in our query. So I can also add a comment here to say for each of the fields, we check if it is sum, maybe some value, and then include in the query. So that is one way we can know if it was sum. Again, remember our struct is supposed to have optional fields as well. So what I can now do is in here, if again, because I'm working with a stream, I would have to, of course, use quotes, because that's also one way. Otherwise, I would probably not be able to actually have access to that value. So anyway, I can use quote one more time. And in here, what I can now do is if let's simple, like this is straightforward Rust. So again, I'm going to use a reference, because again, I'm passing this by reference. So I'm looking at the value that's going to come from, again, remember I was using ampersand to look at these values. So here I'll say field name. So if this actually does exist, what I would like to do is to, let me see. And now I can access this value here. So I can say query paths. So query paths, let me see. So I can do something like query paths dot push. And what I would like to push, of course, is I'm going to format this. So it's going to be something like a key value way of storing this. So I can say this is equal to this, something like that. And maybe I also put this in, of course, because we are writing SQL anyway, so we have to put it in something like this. And now I can reference the values I created above. So I have my field name str. And now, of course, I am also interested in this value. So that's how it's going to be. But again, I'm going to maybe, of course, close this up, go away. But in case you are wondering why we are able to reference this query paths without, again, referencing it like this, the reason is, of course, because we are creating this within this token stream. So this is already within our AST token stream, and that way we can, of course, reference it. But for the ones we created outside of this, in this case, this query fields, for example, then we have to reference them using this pound sign. That's really the way to go about it. So now I can do our checks. So I can now say something like, if this query paths, if this query paths is empty, now it means, of course, all the provided fields we are actually none, basically. So if that's the case, what we like to return here is a simple query, and we can simply say something like, I can use the format macro to return something that says select, select everything from this table. Okay, that's really it. And I provide the table. We had table name, and that's really all we have to do. So if all the fields provided, we are all none, I first name none, last name none, for example, and then in that case, again, we simply return a query that looks like this. That's really what I want us to do. But of course, when that's not the case, I have to create what's a string that's going to return, that's going to hold more or less what we are returning to the user. So I'm going to say query paths. And what I would like to do, of course, would be to turn this into an iterator. And now I can, of course, call map, not amp. So I can simply call map, and I can simply maybe take one of these and I call it an item. So now that we have each of the query parts, what we can now basically do is to build our query more or less from this. So I'm going to probably do this in a few steps. So I'm going to split the string by this. Remember, we added something like this in our query. So now I can maybe say, let's parts. I'm going to create a new holder in here that's going to contain everything else for me. So I can say item.split, and I provide, of course, what I want to use for the splitting, which is this equality sign. And now I collect. And now I have, of course, my vector of strings. So I need to annotate this. So this would be vector of strs. And then with these parts, I can now maybe do something like parts dot trim, basically. I can do trim method, so trim. And now what I can now do, of course, is when I've done all of this post processing, I can now collect this. This again is going to be vector of strings, basically like what we have here. So I can basically also just copy this, come down here and say something like this. And with my this, and I can now actually join all of them together. I'm using a comma sign, so something like this. And now I have my results. which should of course be a string. So I'm going to annotate it also for clarity's sake. So this is going to be a string. I also close this up. So with my result in hand, I need to also build the other part of my query that has to, of course, join all of them together. That will say something like this equal to this and this equal to this and whatever. So I can call this my where clause. So my where clause, again, I'm going to use my query parts dot join. Again, it's going to use, this is me joining my AND queries. So something like this. And with my where clause in hand, I can now actually complete my query. So now I can actually say something like format, and now I return, come on, I say, come on. Now I say select this, everything from, here I'm going to insert my table name, and I say where, and then I insert, sorry, my where clause, and then in here I can simply pass my table name. And of course, I don't need to reference it because it was defined in here. And this will be my where clause. So basically this, we are done. Actually, there might be some errors, but it's totally fine. We'll come back, we'll fix those errors, and then we see where we are. So what I can simply now do, guys, is to come back in here. And we seem to have some error. So let me see. Yeah, of course, given the way I've defined this, I probably have to make this option as well. So I can say I64. And now we should be fine. Do we have any other error? Let me see. Generic without angle brackets. So now this should be fine, of course. So now, of course, I can change this now to maybe to sum and then provide a value. I don't know, 34. And we don't have this anymore. So, but the interesting thing now for you to note is that, again, of course, I'm going to get rid of this. The interesting thing for you to note that now is that for the fact that we have our procedural macro on top of our struct, and of course providing the name, it means now we can actually say something like let query is equal to student and dot build query. Like automatically we have this function, simply because, again, if you come back in here, we have implemented this in here, and then this implementation, of course, would be the name for the name of the struct that we provided. So by doing something like this, we have this function already implemented for our struct. And what it means at this point is that we can actually now go ahead to basically log what we get here and then see if we actually were successful. So what I can now do is I can come down in here and simply just print this, print line. I close this off, of course, and now I can say our query, whatever, and then we simply dump that in here, query. Okay, and now let's expand, let's open our terminal, and I can say cargo run. And now you see the query we get back. It says select this from students where first name is this and ID is this. And just also show you, if I remove this and change this to none, no, sorry, my bad, sorry. If I come to the ID maybe and change this to none, and we run the query one more time, now you see we actually get that excluded from our query. And what I wanted to also show you is if we change the table name here, change it to student, for example, and run our query, it would, of course, now say select from students. Again, you can, I don't know, say whatever you want to say Anthony, doesn't matter, and then run this one more time. And it should also say select from Anthony. So that's really the interesting thing I want us to do. Again, I would provide the source code to all of this, so please feel free to play around with this. And if you have questions, of course, feel free to reach out, ask those questions, and I will gladly answer them as soon as fast as possible as I can.